So let's take a chance to look at how to make modular visualizations using D3. So here I've gone ahead and done one thing, which is take the rate frequency plot we had before. Here it's on a linear scale, right? And I've taken the code that we have to make the plot and drop that into a function, right? So this is kind of the first step in making this plot reusable. So we have a plot code and a function, right? We can do our data transformation and things, and then we just call that plot. Right, we pass in the data. This plot will accept the data. Go ahead and build our viz. So the use case here really is whenever you want to do more than one chart, or say you want to connect two different charts. If we wanted to keep going before without creating a function, we would have to create a whole nother chart inside of our callback on the JSON load. But here we can go ahead and do all the work inside a function. And if we wanted to create two rank frequency plots, right, we could go ahead and do that, right? We could just call it twice. So we could go ahead and do another rank frequency plot. Right, so this is actually going to give us two plots of the data. So here we've gone pretty far by having a function. We can now arbitrarily make more plots, right? And one of the limitations here is that now, okay, say we wanted to have one of them actually do a log scale, right? We would have to, copy all of our code over into a new function, right? We could do that and have a different function, or we could have a keyword argument in the function, right? So we could have to pass in the scale type, right? And I'm not going to finish this example, right? But we could pass in the scale type, log or linear, right? And then in our code here, right, we could take that as scale type, right? And then here we're defining our scales. We'd say, if scale type is linear, right, we'll do this, and otherwise we'll just use a log scale, right? So I guess that's easy enough. But say we want to change the color, and we could keep going with this to make a visualization, a scatter plot here that is actually a reusable piece of code, right? So here we have our two plots, right? If we want to expose more options, like say we want to now change the width and the height, fundamentally we're going to be limited by what we can do with this type of pattern. So what I want to talk about is the module pattern. So here I'm going to talk about the revealing module pattern, where basically it's just a way to structure your code. You can have private and public variables, functions inside of a module, and then you'll return access to the public functions and modules. Right. So this is an example, and you'll have this link. There's also a really good example in the book by Crockford on JavaScript, which is, if you're looking to dive deeper into JavaScript, is a good book. And I also wanted to point to another inspiration for this type of pattern is D3 itself. So D3 version 3 was written using this exact command, or exact pattern. D3 version 4 uses some of ES6 and some advanced JavaScript, so that it actually looks a little different than what we're going to do, but is the same concept. Where we're wrapping up our code into functions and into modules. So here we have this code as a function, right? If we want to convert this to a module, right, we're going to want to actually have this be an object. So what we can do is I'm going to just go ahead and declare a new object here, which is going to be, so first let's save this. We're going to actually create this into a module. Right, and so we're going to create a more flexible rank frequency plot module. And we can just define an object in which we're going to store this module. Right, so I'm going to create my own vislib, so it's going to be my vislib, right? And just to use a little syntax here, I'll either define it to be, if it's none, I'll define it to just be an empty object. Right, and then instead of declaring a function, actually, I'm going to declare rank frequency plot as a value in this object, right? So my vislib is going to have the rank frequency plot function as the value to this key in the object, right? And here we're just going to declare it to be just a function, right? We're not going to get the data or the scale type yet. So we've declared it to be a function here, and a function on that, and here we're closing that off, right? So it's still just a function defined on that. right? And we're going to want to call this to return a plotting function. So kind of the key piece here is when this gets called, we want to return access to it. So we're going to declare a public variable, right? And we're going to want to give that access to some inner method. So we're going to create one called plot, right? And we'll actually pass that in as plot, right? We're also, to be a little more general, create a data function, right? And that'll set the data on our plot. We could also have, width and height accessors, right? And then this is actually going to go ahead and return this public variable. Right, so what do we want to do? So we want to take our code, we want to wrap it up into these functions, right? So in particular, right here we have all the code to make the plot, right? So I'm just going to go ahead and wrap all this up in the plot command. I guess we can have these things be global. I'm going to wrap up the main pieces of our plot here, where the things that we need the data for, to go ahead and be inside of our plot function. So this is going to be our variable plot, right, is going to be plot underscore is going to be a function, right, which is not actually going to take any arguments because it has access to everything inside here. Right, so we've declared a function on this, and we'll wrap up all the code we needed to actually do the plotting, right? And we're going to want to set the data, right? So here. The data was passed in before, right? But we're going to want a function to set the data. So here we'll declare var data on our object, right, to just be an empty list, right? And we'll have our data setter, right, which is going to be a function. And we're going to want to be able to pass in the data. We could make it a getter setter function here, where we could have it, if there's no arguments in that, we could have it return itself. We can also return a reference to the object itself. So, we can do, if there's no arguments, right? So if we just call this without passing an argument, right, we can return a reference to the inner data. Otherwise, we'll set the data to be equal to what was passed in, right? And we're going to return a reference to the function's context. So you don't need to worry about all this syntax right away. Other way around, right? Var that equals this. That is going to store a reference to the context in which this function is called, right? We're going to return a reference to that function. So this is actually how we achieve the chain syntax. So .enter, .append, because they're returning the core D3 selection, right? They're returning a reference to that selection here, and we haven't gone ahead and done that in plot. We don't need to worry about it. We're just going to call plot directly. Right, so now we've got our object here, and rather than calling our rate frequency plot like this, right, we're going to go ahead and call my vislib dot rate frequency plot, right, which when we call this is going to return a function, right? So we can go ahead, it'll return the function that we can use to create the plot. Right, so here we can say this is, we'll store this in a variable, and we'll call it, we can call this just rate frequency plot, right? So this is going to be the first one. So we call this rate frequency plot 1, right? We've called this function, which is going to return this public, which is an accessor to all of these commands that we need to actually do a plot, right? So now we can go ahead and actually set our data. So we can use rate frequency plot. Right, and we're going to go ahead and set the data function for this, right? I think which we just called data. Yep, called data, right? And we're going to pass in sorted, and we can also go ahead and just make the plot. So rate frequency plot, right? And we're just going to plot. Right, so this should give us our main rate frequency plot. And so we've got our plot main here. Now we can go ahead and add other methods if we wanted, right? So here we could go ahead and create a second plot if we wanted, right? So we can go ahead and create another method off that, right? Set the data and plot it, right? So this should give us a second plot, right? And now we have a lot of flexibility at our hand, so we can add any methods we want, right? Not sure what var our plot is doing there. So we can go ahead and add something that will pick our scale type, right? So here, if we want to go ahead and add another function, which is going to be set log scale, right? We can just go ahead and add that, right? And what this could actually do is override our plot function or scales. So here, right, could reset x and y as log scales, right? So let's just go ahead and put that after, right? And here we go. So we can now set the log scale directly if we want to. And so this varset log scale, right? This is going to be a function, which will go ahead and reset the x and y based on our based on if we call this, right? You could pass in a string here and do what we did before, but this will just go ahead and set the log scale directly. We'll have to do it before we call a plot, right? So here we can just use log, right? And that's going to call our set log scale function, right? So we have that, right? Didn't make any typos. And so now we can go ahead and call that right on here, right? So we can go rank frequency plot2 dot log, right? And we'll have our plot in log space here. And so now you can think about how we could take our rake frequency plot, right? And we can use width and height and anything else you want to build a really versatile plotting command. And beyond that, we can now connect these if we wanted to. So now we have these plots, right? They're connected through this object. We could connect any type of interaction that we wanted between them. So this exposes a lot of flexibility for us.